Enzymes are very sensitive to conditions in the cell, and there's a number of factors which can affect their function. And this particular video focuses on the effect of the concentration of substrates, the concentration of products, and other substances that may compete with the substrate for an active site. Enzymes are extremely efficient at converting a substrate into products. In fact, some enzymes can, in certain concentrations, catalyze millions of reactions every second. So they're extremely efficient. This graph, for example, shows how if you were to increase the substrate concentration, enzymes are able to increase their rate of reaction, and you're going to end up with those substrates being converted into products very efficiently. However, there's going to be a point where when you increase the amount of substrates too much, those enzymes are all going to be consistently busy and unable to actually efficiently deal with those substrates in order to convert them into products. And so there's a particular point called the point of saturation, because those enzymes are all saturated. Every single enzyme is doing its job as fast as it can, and if you keep adding substrates, they can no longer deal with the excess substrates. Now, they will still catalyze those substrates eventually, but it's simply that the rate of reaction will then level off. So after the point of saturation, where you have so many substrates, the rate of reaction will level off. The enzymes are still going to catalyze the reaction though. So one way around this would simply be to add more enzymes, of course. Now, as you increase the enzyme concentration, there's going to be more enzymes to actually catalyze the reaction, in which case you're going to just keep increasing the rate of reaction here. And you're not going to end up with that point of saturation. Metabolic pathways are actually controlled quite precisely, so it's not like if you just have an excess of enzymes in a cell that it's just going to keep catalyzing a reaction and you're going to end up with an excess of products. In fact, there is a process called negative feedback which specifically prevents this from occurring. So this is an example of a metabolic pathway where you have substrate A, which is catalyzed by enzyme 1 into substrate B. Enzyme 2 then catalyzes substrate B into substrate C. Enzyme 3 catalyzes substrate C into substrate D, and enzyme 4 catalyzes substrate D into product E. Now, in an uncontrolled situation, this particular metabolic pathway is just going to keep producing product E constantly. Now, in fact, what can happen is something called negative feedback. And what actually happens there is that product E prevents the whole metabolic pathway from occurring by actively connecting with enzyme E1. And when it does that, it actually changes the shape of the active site and prevents the whole process from occurring. So negative feedback is where the product of a reaction inhibits the enzyme that controls its formation. There's actually two ways in which this negative feedback can occur. So let's just say you took a normal binding enzyme. So you have an enzyme here, a substrate that it catalyzes, and the active site, which clearly the substrate will fit into, therefore the enzyme will effectively catalyze that reaction. Now, in negative feedback, you could take a product from a metabolic pathway and it might actually attach itself to the first enzyme in that metabolic pathway, and we refer to that as an inhibitor. And you have to remember that that inhibitor is a product of a metabolic pathway. And what that inhibitor does is it can attach itself to a part of the enzyme other than the active site, but it does actually change the shape of the active site so that the substrate can no longer fit that active site, and an enzyme early in the metabolic pathway can no longer produce a product, therefore the whole metabolic pathway is stopped. Now, because it attaches itself to a place other than the active site, it's referred to as non-competitive inhibition. Because it's not competing with the substrate for the active site. The other case is when the inhibitor attaches itself directly to the active site so that the substrate cannot attach itself to that active site. And because it's directly competing for the active site, it is called competitive inhibition. So these are the two ways in which negative feedback can occur. An example of negative feedback is the production of amino acids, which occurs in multiple steps of a metabolic pathway. And when an amino acid accumulates, it binds to an enzyme that acts early in the metabolic pathway, becoming an inhibitor. And so for a time, the production or synthesis of that particular amino acid stops. But when the level of amino acids drops, the inhibitor detaches from the enzyme, and then once again the metabolic pathway can occur and that amino acid can be produced.